Welcome to this explainer. Today, we're undertaking a cosmic investigation into something that absolutely defies human logic. We're looking at the ultimate heavyweight champions of the cosmos, objects so extreme they literally warp the very fabric of space and time. We're talking, of course, about black holes. The source material we're digging into today breaks down the science, the myths, and the mind-bending reality of these cosmic monsters. So settle in and let's explore the universe's most mysterious truth.
Section 1. What is a black hole? So, a black hole isn't actually an empty void, like the name might suggest. It's actually a region where matter is crammed into an incredibly small space. And this unbelievable density creates a gravitational pull so immense that the escape velocity exceeds the speed of light. Let that sink in for a second. If light, literally the fastest thing in the universe, can't escape it, absolutely nothing can.
So how does something this terrifying even come into existence? Well, it starts with a cosmic giant. Step 1, a massive star spends millions of years burning its nuclear fuel. Now, this burning creates this intense outward pressure that's constantly fighting against the inward pull of the star's own massive gravity. It's an epic tug-of-war. But eventually, in step 2, that fuel runs out. Gravity finally wins. The star collapses in on itself and then rebounds outward in literally one of the most violent events in the entire universe, a supernova explosion. Finally, in step 3, the core that gets left behind, it's just too heavy to support itself. It collapses inward under its own immense gravity until it literally punctures the fabric of space-time and boom, a black hole is born.
Section 2. The structure of a black hole. Now that we know how this monster is born, let's map out its anatomy. The first, absolutely critical part is the event horizon. Now, this isn't a hard physical surface you could touch, but rather an absolute boundary in space-time. Once a planet, a star, or, an unlucky human crosses this threshold, escaping would require traveling faster than light, which, as we know, is a physical impossibility. This is, quite literally, the ultimate point of no return.
But what if you keep falling past that event horizon? Well, you'd eventually hit this, the singularity. This is the very center of the black hole, and it represents the ultimate scientific mystery. Just imagine the mass of several entire suns crushed all the way down into a single point of zero volume. It's a concept that completely breaks human logic, doesn't it? At the singularity, density becomes infinite, and all known laws of physics, literally everything we know about how the universe works, just completely break down and cease to exist.
Section 3. Types of black holes.
Now, what's really interesting here is that these objects aren't just one-size-fits-all cosmic clones, they vary wildly in scale. Scientists categorize them into 4 distinct types. First, we have stellar black holes, which are relatively small, maybe 10 to 20 times the mass of our sun. Then there are intermediate ones, kind of the elusive middle children of the bunch. Next up are the mind-boggling supermassive black holes. These monsters contain the mass of millions or even billions of suns. And finally, primordial black holes. These are theoretical objects thought to have formed in the very first fraction of a second after the Big Bang. They could be as incredibly tiny as a single atom, but weigh as much as an entire mountain. Crazy, right?
Section 4. Discovering the invisible.
So this begs the question, if these objects emit absolutely no light, how do we even know they're out there? Well, astronomers essentially play detective. They look for the invisible footprints left behind. For instance, they watch for stars orbiting at incredibly high speeds around seemingly nothing at all. They also look for intense X-rays, which are emitted by swirling accretion disks as matter gets violently dragged toward that event horizon. They even look for something called gravitational lensing, where the black hole's immense gravity actually bends and magnifies passing starlight, so they see the impact, even if they can't see the object itself.
And this detective work has yielded some truly massive results, allowing us to identify some famous cosmic giants. Take Sagittarius A star, for example. That is a supermassive black hole sitting right in our own galactic backyard, anchoring the very center of our Milky Way galaxy. Then, there's M87 star. This is the absolute giant that made global headlines when scientists miraculously captured its silhouette in the first ever image of a black hole. These aren't just abstract mathematical equations, they're real, massive objects defining the very structure of our universe.
Section 5. Dangers and scientific facts.
Bring this all back to our initial terrifying scenario. What actually happens if you encounter one? Well, if you fell feet first toward a stellar black hole, you would experience something brilliantly and horribly named spaghettification. Because you're so close to such a highly concentrated mass, the gravity pulling on your feet would be vastly stronger than the gravity pulling on your head. This extreme tidal force would literally stretch you out vertically, while simultaneously compressing you horizontally. It would turn you, or a passing planet, or a star, into a long, thin strand of cosmic spaghetti long before you ever reach the event horizon. It's a terrifying testament to the physics at play.
So, the crucial point we really have to clear up here is the biggest myth in pop culture. Black holes are not giant, malicious cosmic vacuums roaming the galaxy, just trying to aggressively suck up planets. They actually obey the normal rules of gravity at a distance. Let me put it this way. If you were to magically replace our sun with a black hole of the exact same mass, Earth would not get sucked in. No way. Our orbit would stay exactly the same. Sure, we'd freeze to death without the sun's light and heat, but dynamically speaking, the black hole's gravitational pull from a distance is no different than the star it used to be.
Section 6. Future Unsolved Mysteries.
Now, despite everything we've learned, these objects still guard the universe's absolute tightest secrets. These are the burning questions that keep the world's most brilliant astrophysicists awake at night. Like, what truly happens at the singularity when our mathematical equations just spit out infinities and stop working? Does the information of everything that falls in just get deleted from the universe? Because that creates a profound information paradox that completely violates quantum mechanics, or is it preserved somehow? And as we look to the future, what will next-generation space telescopes, peering even deeper into the dark, reveal about those primordial black holes that might have seeded the very first galaxies? The unknown here is vast. Which leaves us with this final, really profound thought. Black holes are so often viewed just as dead stars, the end of the road. But they are so much more than that. They're the ultimate laboratories, testing the absolute limits of physics, reality, and our understanding of existence itself. As we continue to develop the technology to peer closer and closer to the edge of the event horizon, we have to ask ourselves, when we finally figure out the true nature of the singularity, will it rewrite the laws of the universe as we know them? I'll leave you to ponder that one. Thanks for joining me on this explainer, and stay curious.